Hi everyone, my name is Ravi Prakash and welcome to second class of Indices and Surds. So in this class we'll study about comparison of Surds. We'll continue it. In the last class we started this comparison of Surds. We did type 1, this is type 2. So in type 1 what we did? In type 1 we did when sum was constant, right? When sum was constant. Sum constant means like suppose it was root 10 plus root 11 or root 3 plus root 18. So sum of the values inside the root is constant, right? 10 plus 11, 21. 18 plus 3, 21. This is constant. So we had a direct shortcut. We derived the logic and we created a direct shortcut for it, right? Same thing now we'll do. This is for type 2 is for difference constant. Type 2 is for when difference is constant. Now difference constant means what? Difference constant means like root 6 minus root 5. Okay? And like root 14 minus root 13. Okay, so values inside root, okay, like root 6 minus root 5. So 6 minus 5 is 1. Or root 14 minus root 13. Again 14 minus 13 is 1. So without the root, difference is 1. Here without the root, sum is constant. Okay, here without this root, difference is constant. Difference is constant. Okay, 6 minus 5 1 or 14 minus 13. Okay, this is also 1. So how to solve this kind of question? Okay, how to solve it? So before studying it, so we'll learn again we'll create a direct shortcut for it. But before that, what we will see is rationalization. Okay, so we study rationalization and then we can easily do this kind of question. We can derive a logic and we can create a shortcut. Okay, so first we have to study rationalization. Okay, what is rationalization? See, so what is rationalization? See for 2 minutes here. What is rationalization? So suppose a surd is like this. Okay, suppose a surd is like this. 1 by root 7 minus root 5. 1 by root 7 minus root 5. Correct. So you have to rationalize it, right? So what does that rationalizing means? Rationalizing means that multiplying numerator and denominator with its conjugate. Conjugate means numbers are same, just opposite sign. So multiplying numerator and denominator with its conjugate. So conjugate of root 7 minus root 5 is root 7 plus root 5. This is the conjugate of root 7 minus root 5. Okay, just numbers are same, just minus to plus or plus to minus. So if it is minus sign, its conjugate is called plus sign. If it is plus sign, its conjugate is called minus sign. Okay. And here also dividing by root 7 plus root 5. Okay. Because it won't make any difference, right? Because I multiply and divide by the same number, this will be both get cancelled. So no issue. Okay. So after rationalizing, what we'll get here is C. Because this is A minus B. And this is A plus B. So A minus B into A plus B is always A square minus B square. Right? So what you will get here is root 7 minus root 5. Okay, root 7 minus root 5. It's rationalization. Okay. So A minus B into A plus B in denominator, what I'll get? Root 7. A square is what? Root 7 square 7. Root 5 square 5. 7 minus 5 is 2. So I'll get 7 minus 5. And in numerator, what I'll get? Root 7 plus root 5. That is root 7 plus root 5 by 2. Okay. Now one more I'll see. One more we'll see. Suppose it is like root 7 minus root 5. Okay. So what is conjugate? Multiplying and divide by just opposite sign. Okay. So root 7 plus root 5 and root 7 plus root 5. So again in this time, this is A minus B and this becomes A plus B. So what it becomes actually is A square minus B square. So root 7 square 7. Root 5 minus 5 square. Root 5 square 5. 7 minus 5 2. 7 minus 5 2. 2 by root 7 plus root 5. This is it, right? So rationalized form of root 7 minus root 5 is 2 by root 7 plus root 5. Rationalized form of 1 by root 7 minus root 5 is root 7 plus root 5 by 2. This is it, rationalized form. I hope it is clear. Okay, I hope it is clear. So now we have a direct way of writing. Okay, now we'll create a direct way of writing. We don't do this much now. Just observation and a direct way of writing. So what is the direct way actually? So direct way actually is if you have to rationalize root 7 minus root 5. Okay. So what will you do? If in left hand side, that is in LHS, if in LHS it is in numerator, write its conjugate in denominator. That is root 7 plus root 5. Okay. If in LHS it is in numerator, write its conjugate in denominator, root 7 plus root 5. And in numerator you'll write is difference of the squares, right? Simply difference of the squares. So root 7 square is 7, root 5 square is 5, 7 minus 5, 2. This is the right. This is the rationalized form of root 7 minus root 5. Okay, the same, right? The same, no? So look at here. Same. 2 by root 7 plus root 5. So direct way of writing. What is the direct way of writing? If in left hand side, surd is in numerator, okay? So in the rationalized form, write it in denominator. It's conjugate in denominator. And in numerator, you will write the squares of their difference. Okay, sorry, difference of their squares. So root 7 square 7, root 5 square 5, 7 minus 5, 2. Okay, one more. If it was like 1 by root 7 minus root 5. So what is the rationalized form? In left hand side, surd is in denominator. That is root 7 minus root 5 is in denominator. So write in the rationalized form, that is in right hand side, write its conjugate in numerator. So its conjugate is root 7 plus root 5 divided by square difference of their squares. So root 7 square 7, root 5 square 5, 7 minus 5, 2. This is it, right? This is it. See? This is same here. So this is the way of writing. Okay, this is the way of writing. I hope it is clear. Okay. So take just one more example and we can easily do it now. Now see, just take one more example here. Third one. It is like 4 by root 11 minus root 6. Okay. 4 by root 11 minus root 6. So what we'll write here? Multiplying it. If root 11 minus root 6 in denominator, write its conjugate in numerator. Root 11 plus root 6 divide by squares of their difference. Sorry, difference of their squares. Right, difference of their squares. So root 11 square 11, root 6 square 6. 11 minus 6, 5. It is 4 as it is. So 4 into root 11 plus root 6 by 5 is the rationalized form of this number. Okay, now I hope it is clear now. Okay, now let's move to the actual question now. We'll learn the logic and then we'll derive a direct shortcut to do this kind of question. Okay, fine. Now see, this is a number here, root 6 minus root 5 and root 14 minus root 13. So what I'll write is, this is a question, which is greater. So write this, so we'll solve it. We'll rationalize both the terms. Okay, if it is difference here, we'll rationalize both the terms. So after rationalizing, what I'll get is, because root 6 minus root 5 is a numerator. So in rationalized form, its conjugate will be in denominator. And in numerator, what? Square of their difference. Sorry. Yeah, difference of their squares. So root 6 square 6, 5, root 5 square 5, 6 minus 5, 1. This is it. This is the meaning of this first one. Second one again, same thing. Root 14 minus root 30 is a numerator. In rationalized form, its conjugate in denominator. Root 14 plus root 13. And then difference of their squares. So root 14 square 14, root 13 square 13. 14 minus 13, 1. Okay. Now, this is correct, right? So now you can simply observe it. You can simply observe it that root 6 plus root 5 and root 14 plus root 13, which is greater. Obviously, right, which is greater. So root 14 is greater than root 6. Root 13 is greater than root 5. Okay. That means this whole term is greater. Right? That means root 14 plus root 13 has to be greater than root 6 plus root 5. Do it individually, right? You can see, observe it directly that root 14 is obviously greater than root 6 and root 13 is obviously greater than root 5. So two terms, so both these terms are greater than this term. That means the sum also will be greater than this. This is greater. Okay, so that basically means that if this is greater, but it is in 1 by form, this is greater. Okay, if it is greater, this is in 1 by form. This is actually smaller than. Okay, because 1 by a larger number, right? You got this one, right? 1 by 8 is, sorry, I should write like this. We know that 8 is greater than 7. But 1 by 8 is what? Less than 1 by 7. Because now more is the numerator, less is the number. Okay, so here also more is the denominator, less is the number. Here also more is the denominator, less is the number. So this is less. This is actually greater. So 1 by root 6 plus root 5 is what? This is greater. That means this is greater. Okay, because this is derived from this. So actually root 6 minus root 5 is greater than root 14 minus root 13. So now what to do? So in this sum, right, you remember it in the type 1. In type 1, when it was sum, we had taken the difference. Here, when it is difference, take this sum. Okay, so simply what you'll write here, see, I'll now write the question here. Suppose question is root 6 minus root 5 and root 14 minus root 13. Which is greater? So what will you do? What will you do? You'll directly write, what is sum here? 6 plus 5, 11. What is sum here? 14 plus 13, 27. So more is the sum, less is the term, because it is that sum is in denominator. After rationalizing, you have to find this, you have to keep this logic in mind, that after rationalizing, the sum is in denominator. So more is the sum, less is the number. So here also, more is the sum, less is the number. This is greater. Okay. What is the logic here? That when difference is constant, okay, when difference is constant, okay, more is the sum, lesser is the value of that surd. Value of that surd. Value of that surd. Okay. So I hope it is clear. I hope it is clear, right? Any doubt here? I don't think there will be any. So very small example. So let's do a bigger example than this. Difference constant. We'll do one example here. See, difference constant. Suppose the question is root 15 minus root 13, root 29 minus root 27, okay, root 6 minus 2, and root 10 minus root 8. Okay, which is, this is A, this is B, this is C, this is D. Okay, arrange in their order. Okay, arrange in their order. So what you'll observe is, you'll observe that difference is constant. Difference is constant. How? Because 15 minus 13, 2. 29 minus 27, 2. 6, right? So this is root 6. So 2 can be written as, right? This root 6. So root 6, this root 6 minus 2, this 2 can be written as root 4. When compared with all these terms, it's all double root here. 2 roots. Here only 1 root. So if I write 2 in terms of root 4, again 6 minus 4 becomes 2. Already root 29 minus root 27, already difference was 2. Okay. Root 15 minus root 13, already difference was 2. And here also root 10 minus root 8, again difference is what? It difference is again 2. So all are 2, 2, 2, 2. Right, all are 2. So that basically means what? That if difference is constant, so what is the rule? We'll write this sum, and more is the sum, less is the value of that surd. Okay. So what is sum here? So in A, sum becomes what? 15 plus 13, 28. In B, sum becomes what? 29 plus 27, 56. In C, sum becomes what? 6 plus 4, 10. In D, sum becomes what? 10 plus 8, 18. So more is the sum, lesser is the value of the surd. So which is the greatest here? B. So that means B is actually smallest. Okay. After B, it should be next greater value is A. So the next lesser value of surd should be A. After B, A, then after A what? After A should be D and then C. Okay. Don't forget the rule. If difference is constant, then we take the sum, and more is the sum, less is the value of surd. More is the sum. So more is the sum, less is the value of surd. So B has the largest value of the sum. So its value is what? Least. So B is the least value. Okay, I hope it is clear. Move to third one now. Third type. Third type is basically this one. Okay. See. This type where I need to compare between 2 raised to 300 and 3 raised to 200. Which is greater? Okay. So in this type what we do actually, see, again I'll tell you first the logic, then I'll tell you the shortcut. Okay, the logic here is make the power same. Okay. When power is in integers. Okay. Let me write like this side here. When the powers are integers. Okay. Make the powers same. So how do you make it same here? 2 raised to 300 and 3 raised to 200. So between the powers, which is the HCF or which is the highest common factor? So both these numbers, 100 is common. So we'll take 100 out. It becomes 2 cube raised to 100 and 3 square raised to 100, because 100 is the HCF. That is the highest common factor. Okay. So now it becomes what? It becomes 8 raised to 100 and 9 raised to 100. Now it is quite easier. Which is greater? Obviously 9 raised to 100 is greater. Okay, obviously 9 raised to 100 is greater. So what is the logic here? Make the power same. That means this 100 has got no role here. I can simply write it like 8 is less than 9. So 100 has got no role here. Okay. So when the logic is now clear, so what we can do is we can make it a rule here that when powers are integers, simply divide by the HCF. Simply divide by the HCF, right? Because if the numbers are here 300 and 200, what I'll do? I'll simply divide by 100, both these terms. Okay, it becomes 3, it becomes 2. Directly come down here. 2 cube is 8, 3 square is 9, which is greater, 9 is greater. So this is greater. So here also this is greater. Okay, this is the logic. Okay, this is the logic. Now let's do a question here. 5 raised to 75, 5 raised to 75, 6 raised to 50, 3 raised to 125, and 2 raised to 175, which is greater. Right? Arranged in ascending or descending order. So again, what is the logic here? We discussed it. So the rule is when the powers are integers, simply divide by the HCF. So what is the HCF of all the powers? 75, 50, 125, 175. So quite easy to see. 25 is the HCF. Okay, so 25 is the HCF. Simply divide each term by 25. So it becomes 5. It becomes 5 cube. 75 by 25 is 3. Okay, simply divide by the HCF. 6 raised to 50. 50 by 25 is 2. 3 raised to 125. 3, 125 by 25 is 5. And 2 raised to 175. So 2 raised to 175 is 175 by 25 is 7. Okay, so it actually becomes what? 5 cube is 125. 6 square 36. 3 raised to 5. So quite easy to do it, right? 3 raised to 4, 81. 81 into 3, 243. And what is 2 raised to 7? It is 64. Sorry, 128. 2 raised to 7 is 128. 128. So now which is greater? You can easily see which is greater. Which is greater here? So now 243 is the greatest. That means here 3 raised to 125 is the greatest. After 243 it is 128. Okay. That means 2 raised to 175 is then next number. After 128 it is 125. So after 2 raised to 175 it is, what is 125? For 5 cube. Where does 5 cube comes from? 5 raised to 75. So 5 raised to 75. And at last what? 36. That is 6 raised to 50. This is the answer here. This is the answer. Okay. So 3 raised to 125 is greater than 2 raised to 175, is greater than 5 raised to 75, is greater than 6 raised to 50. This is the answer. Okay. So this is about type 3. So when the powers are in integers, simply divide by the HCF. Okay. Simply divide by the HCF. Correct? Okay. Now move to fourth type here. Fourth type is similar one. Fourth type, when the powers are fractionals. Okay. Like suppose the numbers are, which is greater here? If I write 2 raised to 1 by 2, okay, and 3 raised to 1 by 3, which is greater. Okay. So in this case, what we do? So again, similar kind of logic. We multiply by the LCM of the numbers. Okay. So here we'll simply write the logic as when the powers are in fractions, simply multiply by the LCM of denominators. Simply multiply by the LCM of denominators. Okay. So that basically means what here? That if the numbers are like 2 raised to 1 by 2 and 3 raised to 1 by 3. Okay. So what is the LCM of 2 and 3? Okay. What is the LCM of denominators? Okay. That is 2 and 3. What is the LCM? LCM is 6. So multiply by 6. Okay. So multiply by 6. So I should write here multiply by 6 to get the answer. It becomes what? It becomes 2 cube. It becomes 3 square. That is 8 and 9. Which is greater now? 9 is greater. So therefore 3 raised to 1 by 3 is greater. 3 raised to 1 by 3 is greater. Okay. I hope it is clear. Yeah. Okay. Now let's do a question on this also. Let the question be 6 raised to 1 by 12. 5 raised to 1 by 9. 3 raised to 1 by 18. and 2 raised to 1 by 36. Which is greater? This is A, this is B, this is C, this is D. Which is greater here? Which is greater? Okay. So when they studied the rule, right? When the powers are in denominator, so in fractions, simply multiply by the LCM of denominators. What is the LCM of all the denominator? So 12, 9, 18 and 36. Their LCM will be 36. Their LCM will be 36. Okay. So what you can do here is simply multiply all this number by 36. So 6 raised to 1 by 12 into 36. 3 raised to 1 by 5 raised to 1 by 9 into 36, 3 raised to 1 by 18 into 36 and 2 raised to 1 by 36 into 36. What I'm left with is this becomes 6 cube. This becomes 5 raised to 4. This becomes 3 square. This becomes 2 raised to 1. So which is greater? 216. 5 raised to 4 is what? 625. Okay. Then 9, then 2. Which is greater? So obviously this is this B is greatest. So B, then A, then what? Then C, and then D. Okay, so quite easy. I think these numbers are okay for you. Okay, now let's move to the last part now. Fifth part of the comparison. So fifth part is basically when nothing is constant, right? Basically when nothing is constant. We did difference constant, we did sum constant, we did both all these special cases, right? We did a non-special case when nothing is constant. Like for example, root 19 plus root 6 and root 3 plus root 23. Now either nothing is constant, neither sum is constant, nor difference is constant. Okay, so in this kind of case, how to solve? Okay, so solve this kind of cases, okay, when nothing is constant, okay, when no special case. It is a general case it is. So what to do? In this case, square both sides. Okay, that means you take square of root 19 plus root 6 and you take square of root 3 plus root 23. Okay, you can't apply sum constant here, right? You get the logic here because 19 plus 6, 25. 3 plus 23, 26. So very close case. We can't compare. Okay, so in this case, take the square. Now a plus b whole square is a square is 19, b square is 6. So 19 plus 6, 25 plus 2ab. 2 root 19 into root 6. That becomes 2 root 114. Okay, here root 3 square is 3. Root 23 square is 23. So root 3 plus 23 becomes 26. So 3 plus 23 is 26 plus 2ab. So root 3 into root 23, root 69. So root 69. Okay. Now you apply a bit of approximation here. That it is 25 plus 2 into, now what is 1 and 4? So it's approximately what? 10 square is 100. Okay. And 11 square is 121. So it's between 10 and 11 somewhere. You can take 10.5 somewhere. Right, no issue. Here also 26 plus 2 root 69. Okay. So again, what is root 69? Root 8 is 64. Root 9 is 81. So it is somewhere between 8 and 9, right? So you can take 8.5. Right? I know it is not it is not in the middle, right? It's not fair to take 8.5 here, but I'm showing you it's okay. The result is still very clear. Okay, because here you will get 25 plus 21, it becomes 46. Here you get 26 plus 17, here you get 43. It's still a considerable difference. Okay, it's still a considerable difference. Even if it is very close cases, so no issue. So here 46 is greater, so here this is greater. Okay, so this is a special case. This is not a special case, a general case. So how to solve a general case? Simply take the squares and do the approximation. Don't do approximation by core. By core means to a root 114. So don't try to take 10.63 some kind of something value or 2 root 69. So 8.27 kind of value. No, simply 8 and 9 take it somewhere between 8.5. 10, 11 take 10.5. This will be right. Here still it's a considerable difference. 43 and 46. Okay. This is the answer, 46. This is greater, so here also this is greater. Okay, so that's it for comparison of the surds. Okay, in next class we'll see how to calculate a square root of the surds, and then we'll complete it. We'll do practice questions. Okay, thank you.